The integral of 1 over x is natural log absolute value x plus c. The integral of u prime over u, where u is a function of x, is natural log of absolute value u plus c. Although the derivative of natural log of x is the same as the derivative of natural log of absolute value x, when integrating, we don't know if it was originally absolute value or if it was originally without the absolute value, so we always include the absolute value unless the argument or the thing inside the log could never be negative. Then we don't need that absolute value. To integrate number 1, I'm going to take -3 outside of the integral. Hey, look, that is just natural log absolute value x. Here, I think I may have u prime over u, but let's check. If u is p squared plus 1, then u prime equals 2p. I almost have u prime over u. I'm going to multiply the numerator by 2 and then multiply the entire integral by 1/2, just a special form of the number 1, so that I now have u prime over u. The integral of u prime over u is natural log absolute value u. And notice that this argument, the thing inside the log, can only be positive, and so you wouldn't actually need the absolute value on this answer. It wouldn't be counted wrong if you left it that way, though. Perhaps we have u prime over u. If u is t cubed minus t squared, then u prime is equal to 3t squared minus 2t. That is very similar to what we have in the numerator. In fact, if I factored out a 3, then I would actually have that. And that would be my result. When integrating a fraction where the degree of the numerator is greater than or equal to the degree of the denominator, you will have to use long division or creative thinking to split the fraction. Making my remainder -4x over the divisor. That means that this integral is equivalent to this integral. Let's separate. The integral of 1 is just x. Our next integral looks like it might be u prime over u. If so, u would be x squared plus 2, making u prime 2x. If I factor a 2 out of that 4, then I will have 2x in my numerator and will have u prime over u. Now that I have u prime over u, the integral is natural log of absolute value u. And this argument could never be negative, so you could rewrite this as parentheses. When integrating functions that contain logarithms, you usually want to think about doing a reverse chain integration, where u is equal to ln x or something containing ln x, and u prime is 1 over x or something similar. To begin, u is equal to ln x. That would make du over dx equal to 1 over x, so du is equal to 1 over x dx. You don't actually have to substitute any u's into this integral in order to integrate, but I'm going to substitute the u's so that it might be visually clear how we got our answer. The integral of u with respect to u is just u add 1 to the power, that's our denominator. So now replace u with ln x. For number 6, I'm going to take the grouping that has ln as a part of it and make that equal to u. That makes du with respect to x -1 over x. Again, you do not actually have to substitute in any u's here. This is not technically u substitution, but to better visualize, I will replace all our x's with u's. That makes this u to the -3. du is equal to -1 over x dx, so I could just as easily say that 1 over x dx positive is equal to negative du by dividing -1 on both sides. This would be negative du. You can take that negative out of the integrand, and now you can use the power rule. Add 1 to the power, that becomes the denominator. Substitute x. Number 7 definitely looks a little different than what we've had before. When we've had a radical in the integrand, we've usually used u substitution, and we usually chose the radicand to be u. If you do that with this one, it's not really going to help you simplify it. So this time we're going to choose u as root x. How would you know this? You don't. That's why we're doing an example like this. Notice that the power in the numerator and the denominator is the same, so we're going to need to use some long division to help us simplify this one. This fraction can be rewritten as this sum. And we can integrate this. The integral of 1 with respect to u is just u. The integral of 1 over u minus 1, that is in the form u prime over u. So the integral of that would be natural log of absolute value u. Or you could leave the 2 factored out, but you must substitute x in for u's.